Anders, if you just go down a little bit, shortly about the company. Gekkobrain we are experts in custom code and ABAP, and the company was founded because we were involved in a HANA migration project, and in that migration project we had to do a lot of code remediation and develop a tool that could partly analyze and assess the HANA readiness of the code, but could also automatically fix the code so it is HANA ready. And as part of that, we discovered that we could also use some of these methods and some of these technologies to optimize existing SAP systems, even if they're on ECC or if they're on Business Suite on HANA already, or even if they've migrated to S4 HANA. The same tools apply to monitor the system, scan the system, assess the system, and optimize the system. So that's the background for the DevOps tool. Anders will get into more details about how it actually does these things. But you can say in the overall premise is that custom code will be worsened over time. It will mean that your system will degrade in quality and in performance. And there are many reasons for this. It can be, increased use of engines. It can be offshoring faster product cycle and so forth. And what we've seen as an example is one customer is a very classic example of how it goes. They've had, over the past 15 years, they've had 330 different ABAP developers on their system. So you can imagine in 15 years, the amount of code they will have produced, but also the quality of the code. Some will have produced some pretty good code, and some will have produced some pretty bad code. And in order to find out which ones have produced, or which code is good and which code is bad, the best way is to match static checks. So looking at the code from a sort of syntactical point of view, and match that towards the actual performance of the code in production, meaning does it dump, does it produce a lot of errors, are certain user groups affected negatively by that code, and so forth. And then based on that, report back to the technical team management, and they can then see which programs should be fixed, or which programs need special attention. So that's from sort of the technical team or from the management overview. But you can also say, even for the programmer, once he's developing anything, it might make a lot of sense if that programmer already at the point of time where he takes out a program, a transport on a program that he wants to work on, that he at that point in time can see how's this code actually performing in production. So the big thing we're doing is that we're matching production data and production checks with static checks of the code to inform the programmer better, but also to inform the team lead, the management, of how it's going. And the next step in all this is then to use this information to, one thing it does, it creates an enormous clarity. So you have a very, very clear picture of how your system actually looks and how it performs. And it also gives you a basis for having a better collaboration between functional consultants, technical consultants, technical team leads, the release manager, and so forth, the operations team, because they are not talking about gray numbers or feelings or anything like that. They're looking at real facts. So what is performing, what isn't performing. So it ends up being a very sort of action-driven system, where if there's an issue, the issue will sort of find the right person and inform that person that there's an issue in a certain area, and they can then take the right steps to remediate those problems. And that means that you can, very quickly, based on impact, the issues and remediation of those issues will be prioritized. So that's sort of the idea behind the DevOps tool. And you can say, if you then look at what comes out of a tool like that, well, you'll save a lot of money on development. We have one customer with its measurements on. Again, it can be quite difficult to measure, but there was about 15% improvement in how the developers were spending their time. And they have an offshoring agreement, and in that, as part of that, they could save directly on that offshoring agreement. But they could also set up targets for their offshoring partner, which in this case was HCL, and they could say, well, these are the quality requirements we have for the custom code that you're developing, and they could then afterwards measure whether their supplier is actually living up to those requirements. we can see if certain user groups are affected negatively. You may look into SAP and into maybe even Solution Manager, and it looks like everything has got a green light, everything's okay, there are no performance issues. But we go a couple of steps deeper, and we can go all the way down to finding one user or a small set of users, and then pinpoint any performance issues that they're experiencing. And if it's a small group, they might not add a lot to the average. So an average performance will have green lights, but specific users or small sections of those users might have very, very bad performance or constantly degrading performance. So last year they waited 30 seconds to create a sales order. This year they're waiting 1 minute and 30 seconds, and it's slowly degrading, so nobody actually notices that the system gets slower and slower over time, which SAP is famous for doing. So I think that's the key. And right now we're looking into also adding continuous deployment. So once something is deployed, if it's low risk, you actually have the ability of auto deploying. If you set up a certain set of rules, we're adding artificial intelligence to look into if we can see any kind of patterns. We're working with Copenhagen University on and their computer science division or computer science faculty to see if we can define algorithms that can help look even deeper into code and statistics that are being pulled out of the system. So that's shortly what it's all about. It's really a tool for making sure that that there's a continuous improvement in the development operations side of things, and that there's you can say smooth transition between the functional team, the technical team, the operations team, and they're all talking from the same sheet of paper. That was shortly about that. We have a number of customers here, especially in Europe, using it. We have it also with Callaway in the US. And Pridewell, who's also on this call, is our American distributor, and Optimized Solutions, of course, is a partner. So that was real short, high level, and the slides I think you're going to see today. And I think I'll hand it over to Anders to sort of jump into the more technical and detailed overview of this and the demo.
Yeah, I think I have only one. Hi guys, I have only one slide here, and then I'm just going to jump to a live demo instead. And so for those of you who are a bit more technical, then what we extract from your system and put into our cloud environment is the static code inspections. We use procedure logging data, SCMon or UPL data, to verify how much of your code is running and how often. And then we also monitor the performance of your SQL by extracting SQLM data. And very importantly, for the stability of your system, we extract dumps from your productive environment. We look at application statistics, which is information which is available in your system, ST03 and other sources. And how to tie this all together is basically that we look at your transports and your transport patterns, and we use that transport information to alert you before you put something into your productive environment. And so that involves gathering information about what programs call what other programs, and if those other programs are performing badly. And so all these extractors, this is just a few simple transports that you import into your system, and then they shoot this to our cloud, and it becomes available in the cloud environment for you. And then one thing that many of our customers really like is that we gather information for the technical leads or whoever is set up to get this information, and we send it out in this formatted email, which tells the technical lead what specific problems. So this is very much like an application performance management, like a data dog, if you will, for SAP. And so this aggregates all these sources, and it tries to find by a set of rules, it tries to find the information which is most critical to look at now. So it presents this on a daily basis. And like what Jens was mentioning, then this is a very actionable set of problems which our customers use to dive into this and see what's going on. This seems to be very bad. Let's have a talk with the developer, or let's have a look at this program. So if you're super busy, this is going to make sure that you have a look at the most critical stuff, and it can very well be stuff which will fall through the cracks for many customers. But anyway, this list goes out on an email every day. So and whenever you feel like asking a question, please go ahead and do so. Makes it more fun. So I'm going to show you one of our customers, and this is a customer which has a particular large amount of data, a lot of stuff going on with them. I'm going to try to take you through the DevOps cycle as we see it, because traditional DevOps, which is, well, let's say DevOps, if you're familiar with DevOps outside of SAP, DevOps is just a lot about continuous integration and continuous deployment, which is to say that it's a lot about making sure that all the developers' components are ready to be deployed, and then once deployed, that it can relatively quickly be fixed again. And so what we are trying to do here is to create roughly the same cycle in an SAP environment where it normally takes a little bit longer time to get fixes to production, because it requires safety that what you're deploying is a good idea to deploy. So we've designed this cloud around getting clarity of what problems are there, and what is it safe to put something to production, and the same thing with fixes. Like you should really be focusing on. So we have a few dashboards here. So first of all, this is the cloud as it looks like. So it's a little technical because SAP is quite technical, but we've designed this around a few dashboards. So there's a developer dashboard, there's a team dashboard, and an operations dashboard. And these three dashboards here allows you to do, let's say, three different aspects of your IT organization, and three in particular, probably also different groups of people to keep an eye on the deployment pipeline, or transport pipeline, if you want to call it that, from their perspective. So I'll just first show you the developer. When he goes into the cloud, he's going to be logging on, and he's going to immediately see his own dashboard here. So I'm just going to show you some random person's dashboard here. So what you see here is all the open work that he has at the moment, and you can see here that he has quite a lot going on. And here's a new development right here, which has been scanned by us and has been found to have issues which are not good for the HANA database. So we're showing him that before he releases that, he should make sure that he fixes these HANA issues, or looks into them at least. And you can see this one. If you're an SD customer, I think you probably are, then you know MV45 FZZ, and you can see that this is obviously an include that has a lot of versions on it. But the good thing is that there's no problems reported on it, so this gives him a good indication that he's fine. And I'm just going to take another approach to show you something else. Yeah, there's a ton of data. And this dashboard that I'm going into now, it's the dashboard which is traditionally operated by the technical lead, which is basically like all the open transports, and it's also used by the release manager. So if I'm going to go in here, I'm going to say I want to see stuff which is open, not stuff. I can also look at stuff which is in queue, released but not in production. And then I want to have a look at stuff which is dumping, which is over here. right? So let me have a look at something. This is pretty bad, right? So this is high usage. So this is UPL data, and it tells me here that it's dumping. So I'll go and have a look at this first and see what are the dumps. So before I go and have a look at what the developer has done. So you can see here, this is essentially ST22 data. We just group it a bit. So you can see here that these are the fragments which are dumping. So for the technical lead, if he used to be a programmer, this is a very easy way for him to have a chat with the developer and say, you know, you obviously have some issues here at the system no role. So there's memory issues, right? On this, there's a timeout. So there's definitely something going on performance here on this program. So refactoring might be in the picture, right? I'm just gonna go ahead and roll back.
But the developer would be seeing those dumps themselves, wouldn't they, as they're working on it and testing it?
Yeah. So if you are working on a piece of software, it's showing you the dumps from production, right? So this is how we like to feed information to the developer, which is very relevant for him as he develops it in development. And also, and let me show you that now. So I'm going to show you.
Okay, I guess I got confused because I thought we were just looking at open.
Yeah, so
you know, hadn't been released.
Yeah, excuse me for being a really bad demonstrator, because I've been over this cloud so many times that I tend to jump around. So, you know, keep asking those good questions, okay? So anyway, I'll show you the same.
Yeah, because you know, for us, we want to, as we'd like to find the stuff out before it goes in.
Absolutely, absolutely. So that's also what you should do, right? And so this case this is a good case for this is the same case from what the developer is looking at right now. This is the worst case scenario in a sense, right? Because that this already came to production, right? So he can see here that that on this current version it's dumping. It's not really dumping a lot, but it has dumped, right? And then he can see that the other versions have not been dumping. So this is something new. So this might be something that has been introduced in the last version, and that is obviously bad. There's nothing else going on in this one, right? And this is ongoing development. So this means that he should go in where I was before and go in and see why did it dump. So he will have this dump information here available to him, and so he will be able to go into this program and see, you know, this is a critical area of this program. This is I think this is a pricing condition, and so he can go into this pricing condition and make sure that this doesn't happen again. You know, you don't want pricing conditions to dump, right? Because then your prices are wrong. So that would be something for him to look into immediately, right? So looking at this guy's stuff, let's take another guy. Let's take something which is a little bit more spicy. So anyway, yeah, so once your program dumps, you know, if you released it and if you think if there was nothing we could have told you about it, we oftentimes can tell you that this might go wrong. But if you can't see it, then at least this would be the case where, as it dumps, the developer will know exactly, you know, it can dump in a few different places, right? So he will have this information when he starts to do the coding. So this is a similar case to if you wanted to have like a firefighter access to go to production and have a look at ST22 to see if you could find a dump. You know, go back and do some heavy filtering to see if you could get a pattern of the dumps. So we just basically chew that information for you before and feed it to the developer. So, you know, you don't have to go through cases in the ticketing system or whatever. But so I will show you something else. I can also show you stuff which is not dumping, if it makes you feel better. But anyway,
the other thing we were interested in, though, was you said something about a syntax analyzer. So actually looking at the code to see how it was.
Yeah, I'll show you.
Good syntax. And the other thing we were interested in is like a where used, right? If we want to find like where, I don't know, a table is used or.
Exactly. So so I'll get to the where used in a moment. So this is here measures the quality of the code, right? So you can see here, this is pretty bad. This is the one I showed you before. It dumps because of memory issues, right? So there was a timeout and there was a role issue. So, and we found some stuff here. These scans here have these were also here before he released them. So I'll just go ahead and go into this, right? And I can see here that, and if you're familiar with Code Inspector, then ATC or SCI, a lot of people use them, but not consistently. And you should have this talk while you look at the robustness of the code. You know, let's say you have a release meeting. You should sit down. You should say, well, it seems that your code, although not released, many people, they set up this ATC check just before they release their code. But really, this should be an ongoing dialogue, right? So you can see there is.
I'm sorry.
Yeah.
So this code analyzer, is this something that we have now that we should be running?
Yeah,
are you talking about some other third-party thing?
No, this is a standard SAP component called the SAP Code Inspector, or the Static Code Inspector, Transaction Code SCI. Okay. And so, a very good indicator for the robustness of your code is if it passes all the checks in the Code Inspector. And there's a few different checks that you should run on your code. And so customers will do this sporadically. The normal case from the past would be that you look at two things, right? You might look at this once a year and have kind of a housekeeping project. You might look at long runners once in a while to see if there's something which has degraded a lot, and then you will manually go and look at these things, or you might wait until somebody says this is taking too long now. So some user or super user might complain, right? So the idea of this is that this monitors everything all the time. So, and it will find all the stuff which is worth fixing, and it will prioritize it so that you fix what is most important first. And so let me one of these things, right? So you can see here there's a few priority 1 cases on this, and this one is a bad one, right? This is so there's some loops across modularization stuff going on. There's something with the structure of this code, so you want to go in and have a look at line 583 in this program and see what's going on there. And you also want to look at this because this is bad. This is loops across modularization. So this looks very much like this code calls into this include, and in this line there's it branches out into like a deeper nested programming logic, which seems to be a bad idea. So anyway, this typical pattern for this would be if you pass an internal table to another function module, and that function module or that function module will then select many times from the database. Totally typical anti-pattern, which you shouldn't do, which is done all the time, right? So it depends very much of how much data is in the tables, if this is going to be hitting you really badly or not, and from the looks of this, this is a bad one for this customer, right? And the funny thing is that they can catch all this. They can catch all this in many different ways. But one of the ways is that they can have a look at this in development by having a look at the static checks for this, and then what we do is we also gather this program relations. So which also gives us an indication that if you call into if this guy is a guy who is notoriously slow, when you pass him a lot of data, then we know that this is calling this program here. So we will also factor that in when we alert you, if that makes sense to you. So behind this there's an extractor which runs your transport information in, and it collects information about how programs are calling each other, which is what we call graph data.
Excuse me, got a question for you.
Yeah.
Does this run across individual clients? Is it client specific or instance specific, or does it combine all that information from the different ones?
Right. So
does it?
Oh wait, hold on a minute.
Yeah. So
ABAP. I thought just 1 second.
Yeah.
I thought the ABAP code is not client specific. It's
exactly. So the ABAP runs. There's no mandant for ABAP, right? Yeah. So the client, the mandant, the mandt field in SAP, right? So yeah, no, it runs across all clients. But what's worthwhile mentioning is that it just gets me thinking. Like if you might have clients set up, if you have a client in queue where you run a lot of performance tests, or if you have a client, some customers actually have some productive data in development, where they do a client copy of productive data and put it there. But if you don't, then this is the best setup for you, because you will basically have before you send this to queue, you will have a similar situation. I don't know how your systems are structured, or if you do a transport of copy to your queue environment before you release it, or I don't know so much about you yet. But anyway, that would be one way.
Let me clarify my question a little bit before you go on. I think you answered the part about the client, that it does collect across the clients, how it's performing in each one of the clients. But my question now is, between the different instances, does it consolidate that information, or is it instance specific? So QAS versus the dev, does it keep them separate, or does it combine them?
It keeps them separate.
Okay.
So and also what I thought you meant was that if you had load balancing in your application in your production cluster, it also it combines that data. So it will combine, if you have 3 different application servers and you run load balancing in your productive environment, it combines all 3 instances. So
okay.
if you have that.
All right, thank you.
Yeah, you're welcome. So anyway, are you familiar with static checks? What they can do for you?
Nope.
All right. So anyway, so then this will be new to you, but and what I understand is that you're on 740 now, right? So you're on a NetWeaver 7.4.
NetWeaver. Do you know what NetWeaver version we are?
I believe we're on 7.4.
We think that's correct.
All right, cool. Yeah. So anyway, all this is available to you to set up, and these are standard. So the way that SAP has positioned the code inspector, also going forward, is that there's essentially 2 different areas that SAP sees as important, and that we also see as important, which is stuff that hits the that hits any database, including the HANA database, badly, which is stuff like if you do a lot of select singles, or any performance anti-pattern that you can think of, you can find that by syntax checking your code. So if you haven't basically put this into your workflow so that you do this all the time, then it will take a long time for you. When you then scan your entire code base, you will find a lot of stuff, right? And a lot of false positives, because many times if you do a select single on a database, it's not really a big deal because that database is really small. So you want to combine that with the SQL monitoring data, which is what we do. So once you combine these two data sources, you will see that, okay, there is a finding here. It says that you have loops across modularization, and we also see that that it is actually slow, right? So this particular program is slow when it runs. I can see if I can find that information for you in this customer system. So you can see here that we gather a lot of information here about the SQL which is executed on your productive client, and I'm just gonna we have some predefined filters here. So one thing which is interesting, and this is something which will indicate a lot to you if you have some issues on your custom coding. So you can see here there's what seems to be this looks like a body, right? So this is some FI coding which is going on, and it has really poor performance on the database. You can see this is the total time. This is a lot, right? We combine this data, and this is a lot of data for you to take in right now. But so we combine this data to come up with recommendations for you to simply have a prioritized list of what you should tackle first. And once you want to dive into, so a developer would want to dive into this, what I show you now. He would want to dive into this to see, he can see from the point of view of these programs, right? So he will want to have a look at this and see, because this gives you an overall picture of how this code is actually doing the selects. A lot of the runtime of an application is dependent on how the your enterprise structures and your data is in production. So if it goes into a sales organization which is particularly large, it will take a lot of time, and if it is a specific document type, it will do something. The runtime changes totally and does something totally different. And this is all evident in this data here, because this data is basically giving you a skeleton, a runtime skeleton, if you will, of how this program is performing in production. So that's SQL data, or SQL monitoring data. So and that's another thing that we gather in. So I just want to show you also the last dashboard here. And keep in mind that this is a huge amount of stuff that this customer is doing. So anyway, for the ops dashboard, this is when something has been deployed, but something is not quite right? So you can see that this customer here has deployed something here. I'm just going to take something which has actually performance issues, because we found a static check. So they have released something to production with a static finding in it, which is a bad idea, and it runs quite frequently in production. We can see from the UPL data, right? So something which runs all the time, you want to fix first, right? And it even dumps, right? So that is also quite bad. So you can filter this, for example, here. So if you are, let's say that you were sitting in the application management department and you want to have a look at the stability of your system right now, There's obviously a bunch of standard SAP system monitoring transactions that you could use, but you could also choose to target this from a point of custom code. And this makes particularly sense if you don't actually have that, if you don't have the full picture of what custom code is being developed at the moment, which is typical for offshore setups, or even just a group of consultants coming in. And if they are operating relatively autonomously on your system, then you might not know exactly what they're doing. Or it could even be like a third-party component that you had introduced, which is performing badly, right? So let's have a look at stuff which is performing a lot, or which is running a lot, and let's see here. We have something which has dumped. This is dumping. It seems. I would just have a look at the dump. So rather than going to ST22 and looking at the list of dumps, then this just gives you a you can see here. This is this is another memory issue. So you can see that the tables which are involved, right? And you can see here that again, this is a page allocation fail. So this is bad and timeout again. And here there's even something which might be related to this is a plant maintenance thing. So this might be even something with the authorizations, right? But okay, so let me know if this makes sense to you. So this basically gives you normally this takes you a long time to find all this information, and normally this is something that you will ask the developer to do, and he will still have to do this to be able to fix the program. But this is all the data which is needed to make sure that this doesn't happen to the program again. Rather than he gets a ticket in where it says we think this program is running a lot slower, or this was this doesn't seem to be providing the same data anymore as before, or this dumped for this and this user. Then you can see he will be able to see exactly how many dumps, what line it was dumping, and for what reason it was dumping, and then you will be able to go back and apply that when he refactors the code. And then of course it should pass all the static checks before he releases it again. Let me show you also what Jens was talking about before. So Jens should get into the try to show them also a little bit about the dashboards for the getting ready for HANA.
Yeah, I think it makes sense.
Hold on, before you get into the HANA, what about the where used?
Okay, so
we're not really at the HANA phase yet.
You're not a HANA phase per.
No, but I think what Anders will show when he shows you the HANA stuff is even if you're not in a HANA phase at this point in time, at some point you have to be. And with this tool, it keeps alerting into any HANA issues. So whenever again a developer takes out a program, it will also show him if there are any HANA issues, and he can then get that fixed already at that point. Or if he's developing something new, it will also alert him to the fact that he might be actually developing something which will be hit by the certifications in S/4HANA, which might be a bigger issue at that point in time. And then you can already at that point start taking care of that, taking that into consideration.
Yeah.
Sure, but we want to see the where used first.
Sure. No worries.
You want to see the where used. Okay, so you can't actually see the where used. It's we feed it into the system. We will be developing a graph which tells you two things. One which is like a graph data, and the other one is more like a pattern dashboard where you can see often used fragments of code.
Okay,
so
can you hold on a minute? Just
Yep.
a minute. David, can you give them an example of what it is we want to do?
Basically, if we take a, let's say a table is the easiest one, and you want to see where that is used at.
What?
Or a function module. Function module is probably the easier one. I've got a function module that is out there, and I want to see which programs are using that function module, so that if I make a change for it, I know what it's impacting.
Yes, very good. So that is exactly so we have that data in the system, and so think of it this way, right? So it's a simple list for us to drag that out of. So yeah, so it's we don't have a list in the system right now, but it's coming quite shortly, which gives you a list of all the and this list is basically so if you have this going back to the dashboard, this is a list which is in popular demand, so it's coming quite soon. So anyway, so think of it this way, right? So this one here. So what we've done is that we have gathered information about exactly what you just said, right? That what are the relations to other programs, right? And that is one thing which is important. So there's two sides to this. One, if this program is a new program, I can go down to something which is new, right? So this is a totally new program, right? So we won't have any intel on this program by itself from production, obviously. But if it's calling into something which we know something about from production, so we will alert you to that on this list. So we will say this is calling into a function module which we know is performing badly, or is it dumping, or it's dumping in production. So it will be shown here. It will say here shortly, very soon now. It will show you here, problems with related programs. And when you click that link, you will get into a list of programs where which seems to have issues. Hopefully, only one, right? So that will then give you. So that will just take you to this view, but for the program which it is calling. If you can understand what I mean. So it will just be one where it will no longer be the program itself, but it will be the program that it's calling, and it will change the aspect into the program that it's calling. So it will show you the data for the called programs. So as you know, and it might be this is not going to be happening in real life, but this program here might be calling this program, right? So this program here doesn't have any problems, but this program has a problem. So it will say, this one, and then it will give you a list of the programs which has problems underneath with the problems that they have. So all that data we have available, we just haven't made that list for the developer yet, because it was it has to be done just right. So that's the graph data which we are collecting, and then we will show that to you. So there's a bunch of other stuff that we're also working on, which is to try to compute the estimated runtime of the program. Like if you have a new program here, then it would be fun, wouldn't it, to see that if you call this program and we know that you are these are the tables which you are calling, then we think that you have a long runner on your hands. If that makes sense to you.
Right.
But anyway, the graph data is right around the corner. It's essentially a no-brainer by now from the data that we have gathered.
Okay.
Tell this feature already. Yeah, but and it's also super important. And trust me, it's right around the corner for you to see this information in the system.
Okay.
Yeah. So just getting back to, I know that you're not considering HANA at the moment, but a very important thing is to not introduce more HANA issues than you need to. So you want to. Our recommendation to customers that are not, right now considering to go to HANA is still to make sure that the HANA journey is not getting more and more difficult, right? So I'll show you this. So this is the customer here made. They made us some scans, and they found out they had a long way to go, right? I'll drag it for here, right? And so what they did is that they cleaned this up, and so they've been able to keep it relatively flat, but they are still, sadly, they're still introducing a few things, and this is not surprising when you now saw that sometimes they do release things which has HANA issues in them. But this is a relatively flat curve, and you want to make sure that it doesn't go up again like this. And and the same goes for you, right? You might be up here, but for everything that you touch in development, you want to make sure that you fix the things which are HANA related, which are oftentimes also very good practice for a conventional database. And so with any luck, you will see your graph coming down slowly but surely, right? And that would be that's a very good idea. And then you will have a more stable system. And once you come either to HANA, Suite on HANA, or to S4HANA, which is also on a HANA database, so your custom code will have the same, will need to be modified in much the same way. But then you basically want to do this whenever you look at a piece of code which you are putting to production. You want to make sure that piece of code, it only takes you like maybe another additional 30 minutes to fix the issues which are popping up. Otherwise, you have to go and do and we also offer you, as I'm sure Jens or somebody else has told you, we can also convert your code automatically for you and fix many of these issues once and for all. So we do that as well. So, for example, if you have a lot of select stars, it makes sense to fix these if you want to have a bit better performance in your system, like a field list instead of an asterisk is something which dramatically increases or decreases the runtime of a program, and we do those fixes automatically.
Okay.
All right.
Yeah. So any other questions to this?
None for me. None
Okay.
for me.
So if we talk about sort of the next steps in this, what we normally do, I know you've been offered a 3-month trial of DevOps, and in order for that to work, maybe Anders, you can just briefly explain sort of the process from this point. We set up an account for you, and then the next 2 or 3 steps you need to do in order to have access to your data in the Gekkobrain cloud.
Yeah, sure. Yeah, so basically we register you in the cloud, and there's this is pretty self-explanatory, but anyway, otherwise there's you can follow the guides, and then what you do is that you have in here a series of extractors that you proceed to download and you introduce into your system. This is all explained in the guides, and then you basically you just introduce them to your transportation management system, and you push a few of them to production, and some of the other ones can just be in development. That's fine. And then once that's done, you start monitoring here if you are starting to receive, if data is flowing in. So you can see this is the customer system here. You set up your systems from here. So this customer here has set up not that many systems, but he has a development system and a productive system, and he actually also has his queue system in here. And then he has another development environment, which they are looking at now because they want to get that system onto HANA. So then you set these systems up, and then afterwards we have a bunch of different extractors, as I said, and you download those and introduce them to your system, and you set these extractors up as projects in here, and these projects are then listening to your system and basically correlating the data on the cloud side and presenting it to you and giving you the dashboards that you need. And then if it finds something which is really critical, it sends you the email. And it's I think we find that it works very well because the developers, they know the code very well themselves. So this gives them a very good view of the dynamic data which comes from production. So it's a pretty immersive. What's the word? It gives them a lot of details which will benefit them. And anyway, this is quite quickly set up. Most of these extractors, they run for a very short time. So the code inspections take a little bit longer time if you have a lot of custom code. And it's explained there in the guides how often we think they should be run. Normally, the frequency is around every 24 hours. And so it's data sent there via HTTP to our cloud.